All right, guys. So I guess I am audible to all of you, correct? Okay. Let me check whether I'm visible to you or not. Hmm. Okay. All right. So I guess I'm audible to all of you, correct? Just give me a moment. Yes, all right. So I guess I am both visible and audible to all of you, right? So, guys, today we'll be actually discussing about that the kind of questions that we are expecting actually. Okay, and basically, if you just look into I'm going to tell you like whenever we are going to give any exams or something, there are some basic mistakes that we have been keep on doing there. And I guess, guys, right after the exam is over, most of the time we feel like okay, we have made this much of bad mistake, and because of that, we are losing a lot of marks for that, right? So I'm going to start today's session with a very like a real life example that I have been going through recently, that I have faced recently. Okay, so I'm going to share that experience with all of you. So recently, I have been giving an exam just to check QC the papers in here, and I was just checking, how the question papers are coming in. Ask writers about the quality of the question papers and what all mistakes are there. So we do this kind of stuff, this kind of practices over here in Ask Writers. So I was just going through that, and there, what I have realized it, I have given a test actually. Okay, I've given a test in the medical test as well over here. And in that test, what I have specifically seen is I have given the test exactly in 1 hour, which is a student is supposed to get that much of time only. I have taken, and I'm going to share my experience with you guys there. So in the end of the session, in the end of the test, I have seen when I saw the question, when I saw my result, I saw that I have made two mistakes in that paper, and both the mistakes are actually very, very simple. Like I've been making mistakes in something like Lashatelier's principle, guys, which I think like all of you would be laughing at me at that moment, right? Sir, you are teaching for these many years, 4 years so far. How can I make mistakes in Lashatelier's principle, right? So, guys, there is something that I have learned that day, and that is what I'm going to share with you. So, I guess you do believe that that was not a problem with respect to my knowledge, right? That wasn't a problem of my knowledge. The major reason behind me not being able to like making those mistakes is I was out of practice. Now, I'm not really saying that I'm out of practice with the questions. I'm saying that I'm out of practice handling that pressure. I'm out of practice working under the clock. And not only that, guys, what I have noticed is when you give an exam, you start self-doubting yourself. We teachers, we are away from these exams and all. As a result, we don't feel the same way that you're gonna feel. And guys, even after teaching for these many years, if I am self-doubting myself, then I guess all of you would be, definitely, right? Now, my point right now is, so what all things are there? So right then and there, I have decided, I need to make this webinar so that I can pass along my experience with all of you. You'll be under a bigger situation. You will be under a bigger, I mean, the stage will be bigger at that moment, right? So there is a huge chance for you to make these kinds of mistakes as well. The kind of things that I have done. Definitely, you can do those kind of things as well. So, guys, how can you get rid of them? What all methods are there that you can follow at that moment in order to um, get rid of these kind of mistakes that we have been doing? Okay, and specifically, in which all places do we make the mistakes? Right. So this is the entire discussion that we are going to have today. And guys, in the end of the session, I'm going to tell you what was the mistake that I have done. What was the mistake that I have done in that paper that which caused those two questions wrong. Okay, so you can clearly understand I am gonna just watch this video till the end, and in the end of the video, guys, I'm gonna tell you, even at this stage of my life when I'm teaching chemistry for these many years, what is the mistake that I have done at that moment. Okay, so, and I'm going to tell you guys, each and every student, each and every faculty in this field can make that mistake which I have done in there. So you need to know what really happened with that, right? So let's start with the first discussion as how can we minimize the most amount of mistakes that we do. Okay, what all things can we do in boards examination? Guys, this video is completely based on your boards examination. For your JEE and NEET, you cannot follow the same methods. Okay, you are not gonna have that much of time to follow the same methods. All right, so this is totally based on your boards, right? Okay, whenever I'll be writing something, guys, I'll be looking at my left hand side. Okay, so I have another screen there. So as you can see, the first point that I'm writing as the points to remember is the first point is cross verification. Now, I guess all of you know that, so we know that we need to cross verify it. But how? How would you cross verify? So if I ask you the same question, you would go like, sir, what we would do is we would just read the question again, and then we read the answer again, and we would see that whether we have made a mistake or not. Now, I have done that as well. Okay, and I believe every single student does that. But still, guys, you will be making the mistakes because the point is, at that time, now, if you have made a mistake because you are, when you were solving it, you couldn't see something, right? That is why you made the mistake. Let's say there was a mistake in units. Let's say you made the mistake in units, or let's say you made the mistake in a calculation. You can make the similar mistake one more time. So that's not the clear way of cross verifying, guys. It's not the right way of doing it. All I'm telling you is you need to know another method of solving that same question. Are you getting my point here? That means you need to know more than one methods to answer a question. One method would be the one you'll be using in the exam, and the second method is something that you'll be using in order to figure out whether your answer was right or wrong. And that means you might be thinking, sir, in that case, so right now to get one method, we have we have used our entire year. Now you're asking us to know another method for each and every question out there. Is it possible at all? The answer is yes, it is possible. So let me tell you, it's not like I'm asking you to learn something new right now. I'm asking you to do some, back calculation for that. So I'm going to give you some examples right here. So you can clearly see that I have given one question which goes like, what are the products obtained when orthoxylene is treated with ozone in presence of zinc? So what are the products that we get when orthoxylene is treated with ozone in presence of zinc? That's the question they are giving. Now, guys, first of all, you start with the question as orthoxylene. So orthoxylene means you'll be having the benzene ring there. One CH3, another CH. So this is the orthoxylene molecule or xylene molecule, same thing. Xylene or orthoxylene. Okay, I'm gonna zoom in a little bit Make this a little clearer to you. So this is your orthoxylene molecule, right, guys? Now, in this orthoxylene molecule, the question is, what would happen if I ozonolize this molecule? So what would be the product? That's a very simple question, isn't it, that way? So like you just ozonolize it, and you know, guys, how to perform the ozonolysis. Like the shortcut goes like, you break the double bonds and you put double bonded O there. So if I zoom in right now in order to make it clearer, so the first product that you would get is this CH3, CH3, C double bonded O, C double bonded. So let's write that one. So you have a CH3, then you have a carbon, then you have a double bonded O, bond a carbon, then a double bonded O, then another CH3. Correct? This is one fragment that you would get in here. Right, guys? Clear? Now, the second fragment that you would get over here is this one. So that contains, let's draw this carbon. These are the two carbons over here. So carbon, carbon, double bonded O, double bonded O. So every single double bond would become double bonded O here and the hydrogens. And if I break this fragment as well, you're going to get the same. Right? So this is the product that you got in the examples. Okay. But then what I'm asking you to do is I'm asking you to cross verify it. Now, how can you do cross verification? So now you do the backwards approach in order to find out the reactant. Now, I'm telling you guys, from the products, you see that whether you are getting the same molecule, which is a reactant molecule or not. So now what you're going to do is you draw this molecule one more time. So guys, your target is now to make benzene out of it. I mean, orthoxylene out of these three products. So first, you do this. Like I said, guys, I'm not asking you to follow my method when you are giving JE. I'm asking you to follow my method when you are giving boards, because you can clearly understand this cross verification method would be a little bit time consuming for all of us, right? So I'm not asking you to do this in JE or NEET, not any competitive examination. But in boards, we can definitely, in the end of the paper, we can have this much of time to just cross verify it. If I just take out the oxygens, then it would be a double bonded O, and guys, I'm gonna get orthoxylene back. That's the only cross verification we're talking about here. Okay, so you'll be getting orthoxylene. Now, let's give you another example of the same type. Let's say you have this question. When a molecule A is treated with NaOH, the product obtained is this molecule is given to you. Okay, the product is this. This is not molecule A, the product is this. They are asking the formula of A. See, this is not the exact question which came in the last year's board examination. So I'm just giving you the part of that question. Okay, you have to figure it out. And now, guys, how to solve these kind of questions without making any mistakes? First of all, in organic chemistry specifically, guys, this is something I would suggest all of you to do. So what we do is actually we look at the reactant, then we remember the reagent, and then we learn how to make them react together to get the product. Correct? Now, I don't know whether you are one of them or not, but guys, there are very few students out there, those who can look at the product and tell which reaction is this. There are thousands of students out there, guys, who can look at the reactant and the reagent and tell me which is the name of the what is the name of the reaction. But by looking at the product, there are very few students those who can figure out what is the reaction out there. And guys, they have been giving you these kind of questions as well, where they will be giving you the product, they have to figure out the reactant. So that means, guys, right now onwards, whenever you'll be revising organic chemistry, start looking at the product, start figuring out what is speciality of the product. How can you recognize the entire reaction by just looking at the product in there? All right. So now the product that is there in here, guys, you can pause the video for a second and figure it out. What is this product? What is this product famous for? So I guess all of you have tried this once before playing the video back again. This particular product, guys, it's a famous product which is alpha beta unsaturated carbonyl. What is this product, guys? It is alpha beta unsaturated carbonyl. We all are preparing for JEE or NEET, right? So as a result, guys, these kind of questions are also useful for your competitive exam preparation. Correct? So alpha beta unsaturated carbonyl is here. Now, alpha beta unsaturated carbonyl is the product of aldol condensation. is the product of aldol condensation. Correct? So what is the reactant in? Now, that means, guys, again, what you have to do is you have to go backwards here, right? So from this molecule, how can you go back in order to figure out the reactant? So what you are supposed to do is first, try to understand how did this double bond. If you remember, guys, there was a OH and there was a hydrogen from which you have taken out water in order to get that double bond. So just the step before this was a OH and a H. Now, you know, aldol is only being performed by the aldehyde or the carbonyl compounds, as I will say, the carbonyl compounds with alpha hydrogens. Correct. So now it used to be a carbonyl compound, right? So the OH, which you can see over here, it used to be a carbonyl compound. So you make this double bond, this bond break and come back to make a ketone and break this one. So the product that you would get is CH3 C double bonded OH plus CH3 CO3. This is the approach that I want all of you guys to look at. I want all of you guys to know this approach towards every single organic molecule reactions. Like, so the target is how to figure out the reactants from the products. If you know how to do that, guys, then there will be very few questions that you'll be confused about. So you can, anytime you can cross verify your answer by just going back down, back again, and whether you are getting the same product. So let's just cross verify this, whether my reaction, whether whatever product that I got, whether that is right or not. Okay. So what am I going to do, guys? I'm going to react them together to make the aldol condensation, right? So the aldol condensation would be, I'm going to give you some enables. So both of them has alpha hydrogen, as you can see. So definitely they can undergo aldol condensation. Yeah. Now, what was the shortcut that I taught you in the classes, guys? In order to make aldol condensation, you have to tilt one of the molecules and keep the other molecule straight. Whichever molecule you are keeping straight, make sure the alpha hydrogens are drawn out. Now you take out the water from here to get the final product. So the final product looks like CH3. Then we have CH, double bond CH, single bond O, CH3. This is my product. If I do the forward reaction, then that is giving me the final product that has been asked me. So guys, you can clearly see that what I have done is, first I figured out the answer, then I have gone again in order to cross verify it, whether I have got whatever answer I've forwarded that is correct. Okay, I'm gonna tell you, if you are using this method, you would be taking not more than 1 or 2 minutes for your cross verification. Yes, it would be taking a little bit more time, guys, than usual. But in the end of this method, in the end of this process, you would be 100% assured that your answer is correct. Okay, so this way you can definitely eradicate your slip mistakes. So now, how can you incorporate that in your boards examinations, guys? Definitely, first you write all the answers. Okay, don't try to cross verify them right then and there. Okay, that takes you down to my second point actually, space for recalculation. I'm gonna explain this thing, but right now, guys, even in organic also this works. For every single question, after writing them, you keep a little bit of space. In that space, you are going to do the back calculation if you have extra time. You have to save at least, guys, 15 minutes from your board examination. So first you get it over with, complete all the paper, entire paper, try to save 15 minutes, and you have to do that, guys, for your cross verifications. Now you come back. In those 15 minutes, what you have to do is the places that you have kept in there for your recalculation, you just do the back calculation for the important questions, not for every single question. You won't be having that much of time. All the questions with the 3 marker or the 2 marker questions. Okay, those who contains more weightage. So that do this method for those questions first. If you even have more time after that, then guys, if definitely you can use this method for every single question and for organic chemistry specifically. Okay, so this was the first thing. Now let me check whether I was audible all the time or not. Yes, I am, right? Great. Now, guys, coming to the next point here, space for recalculation. Now, this particular thing is actually for your physical chemistry, but you can clearly see that, guys, this is needed for every single question, but it is mostly needed for your physical chemistry specifically. So now, what do I mean by space for recalculation? So guys, here specifically what you have to do is right after every single physical chemistry numerical problem specifically. Okay, I'm gonna ask you to keep at least 3 to 4 lines. See, that's gonna give you two things, two benefits. Definitely, that's gonna give you some space for your mistakes. You can rewrite that question in there, answer in there. That's one of them. And the other one, the other benefit that you're gonna get is your copy is gonna look cleaner, right? It's going to look much more tidy, right? So that's the another benefit of this. So always keep some space. I'm going to tell you guys, there have been multiple times when I have given a subjective level exam, and in the end of the paper when I am rechecking it, I figured out, like, I remembered a few points, and I wanted to write those things. And you won't believe me, guys, it has been happened in my life twice, that because of those points that I have written in the end, I got full marks in those questions, because those are the exact points they were looking for. But when I was writing the paper, at that time I couldn't recognize that. I didn't, recall that particular points. But when I came back, I was rechecking. By then, I was pretty much confident. I was warmed up by then, right? So as a result, I was, very much accustomed to the situation, environment as well. So as a result, when I was rechecking the question, all the things were coming up in my head, and I was just writing the notes, the extra points in that extra space that I have kept. Okay, so right now, space for recalculation. What is the benefit of this? Let me show you one. Let's say they have given you this particular question. If you can see, I guess it is visible. Yeah, it is visible. So the thermal decomposition of formic acid in a first order reaction, the rate constant is given to you guys at a certain temperature. You are 100% going to be sure that one kind of questions like this is going to come. Okay, guys, so make sure that you're practicing these kind of questions from kinetics. Calculate how long will it take for 3/4 of the initial quantity of formic acid to decompose. That's the question given. So guys, how to solve this kind of question? Let's say you are in a hurry and you solve this question like K equals to 2.303 by T log of R naught by R. This is the equation. For first order kinetics, this is the decomposition reaction, guys. Always remember decomposition reactions are first order, correct? So now the R naught value is given to you as, let me see, how long will it take to 3/4? Let's say R naught is 1 and R is 3/4. Okay, I've given that. So R naught is 1 and R is 3/4. Correct? And you have solved this entire question. And specifically in these kind of questions, guys, we make these mistakes. If you see, how long will it take for 3/4 of the initial quantity to decompose? How long will it take to 3/4 of the initial quantity to decompose? I guess by now you have recognized what is the mistake that I have. But guys, tell me one thing. While you were solving these kind of questions in the beginning, you have made this mistake that I have done, isn't it? All of you have. Now, telling you one more time, if you are, I can understand that you might be thinking like, sir, what is the mistake that you're talking about is, it's very easy. We have all been aware with these kind of questions, and we have practiced these kind of questions a lot. But guys, let me tell you one thing. You have never been in this situation before, right? This is the first time you're going to go into that situation. Like, let's say you have started giving an exam, and for some reason, for XYZ reason, your first question didn't went according to the way you thought it would. It didn't went along according to that much. Good. In that situation, what we do is we start panicking. We lose our calm. And in that situation, you don't know what kind of mistakes are we capable of. I'm telling you this, guys, from my personal experience. See, there is nothing wrong to be extra cautious about something, right? There's nothing wrong with it. So right now, the mistake that I'm telling you right now here, guys, they're saying 3/4 of the reaction initial quantity. How long will it take for 3/4 of the initial quantity to decompose? 3/4 of the initial quantity to decompose. So guys, what is the value of R? R is not the amount which got decomposed. R is the amount which is left. I guess you can relate what I'm trying to talk about. So guys, it's going to be 1/4. 1 minus 3/4. It's going to be 1/4. Now, we are capable of making this kind of mistakes, isn't it, guys? So the moment we made this mistake, what we are going to do is, when you will be rechecking this question, always remember, guys, for physical, chemistry, mathematical, numerical kind of questions, Never recheck the numericals like this. Okay, if you have 2 minutes, just make sure that you write this question one more time, solve this question one more time from the beginning. Now, I'm not asking you to solve the entire question. I'm asking you to do the equation, write the equation, and put the values from the question one more time without looking at whatever you have done. So start fresh, write fresh. So I'm telling you, you do it one more time. So k is equals to 2.303. Don't look at the left hand side while you do that. Don't look at this side. You just consider that this is gone. 2.303 by t log of r naught by r. Write it one more time. Put these values one more time without looking at your left hand side. There's a like 1% chance, guys, you'll be making the same mistake one more time. Is very less likely to happen. So now next time when you're putting, you'll be able to see the R naught, it's going to be 1, and the next time when you'll be doing this R, you'll be much more under less stressed condition because you have given the entire paper by now, right? So you know how the paper went for you. So you know about that. So now it would be much more easier for you to crack that answer. It would be 1-4. Now you check it, whether you have given 1-4 or 3-4. And if you have given 1-4, then guys just take the calculation a little bit, and that's it. That you can do. Right? So I'm asking you to devote your 10 more seconds in order to put the value in. All right. So this is going to be your master, you can say, advice from my end, guys, for your physical chemistry questions. All right. Now coming to the next one, which is the kind of mistake that we do in electrochemistry. Okay, I'm giving you the kind of mistake that we do in chapter wise now. Okay, because this has been seen in so many years back then as well. And now I've been seeing this year after year because so many students of mine have been doing these kind of mistakes, right? So sign convention mistakes. So guys, there is something that it is very likely to happen for all of you. You can see when we are talking about the sign conventions, we mostly make these mistakes in two chapters. One is electrochemistry, another one is thermodynamics of grade 11. Right. I guess you do agree with me. In thermochemistry, we make this kind of mistakes, the sign convention kind of a mistake. Right. Now the point is, right now thermodynamics is none of your business because right now our focus is boards. So considering that, electrochemistry is the one which can put us under this much of pressure right now. Now, what all points are we more prone to make mistakes? Always, guys, triple check or quadruple check the values that is given to you. 3 to 4 times you check it. Just check that whether they are giving you both the values in reduction potential or not. Okay, there might be many of the students, those who are comfortable in solving questions in oxidation potential, right? But guys, I would suggest you, to all of you, to solve every single question in reduction potential. If you do not have the value in reduction potential, convert it into reduction potential and solve the question accordingly. Because guys, all the equations those are there in this chapter are made on the basis of reduction potential. You cannot solve the single question with oxidation potential using the same formulas that you have learned in electrochemistry here, guys. For oxidation potential, like let's say E cell equation, it gets completely opposite. It's not E cathode minus E anode anymore when you are using oxidation potential values. I'm not trying to confuse you anymore, guys. So that's why I'm telling you, always turn everything into the reduction potential before you solve the questions. For solve the numerical questions. For analytical type of a question, let's say they have given you which one is more oxidizing agent. They have given you all the enol values. Which one is more oxidizing? In those questions, you don't have to worry about. But the question, those who are related to the values are given, and you have to figure out. You have to numerically figure out. In those questions, guys, always make sure that you have your values in reduction potential. As of right now, you can see that all the values are given in reduction potential. But guys, be 100% prepared for a situation where they would give you 3 of the values in reduction potential, 1 would be in oxidation potential. Means they can give the last value as Fe2 plus Fe3 plus. No one would see that, and everyone would solve this question wrong right there. Because 3 values are reduction potential, 1 is oxidation potential. You would never be able to solve a single question with these values. You have to convert all of them into reduction or all of them into oxidation potential. Right? We all know this. So considering that, guys, you have to make sure that every single values are in reduction potential before you solve these kind of questions. Now, I guess these are not the problem, the questions that you can make mistakes in. It's just cathode minus anode. And I guess, guys, we all know there's another thing in electrochemistry only where we make the most amount of mistakes, which is, guys, I guess you all have noticed that in electrochemistry we talk about both the cells, electrochemical and electrolytic cell. Till Nernst equation, we are talking about electrochemical cell. After Nernst equation onwards, guys, we talk about electrolytic cell. From where we start that Faraday's law and stuff, that is all electrolytic cell, right? So I guess you have noticed that till Nernst equation, the cathode and the anode, and after Nernst equation, the cathode and anode are not the same, right? So it's pretty much confusing for us which one is cathode and for which one is anode. Okay, you might be saying, sir, I'm pretty much clear right now. But guys, I'm giving you one more method of doing this, of figuring it out. Those who have been taking classes with me, they know the methods that I use, and I'm going to give you a very easy method, guys, right now. Keep it with yourself. Like I said, now you should always have more than one method of solving a question. So it might be helping you in cross verification. Right? Always go for the alphabetical order. Always go for the alphabetical. Always. Okay. Always go for alphabetical. Always remember one thing. If I'm talking about anode, there you would see oxidation happening. If I'm talking about cathode, there you would see reduction happening. Just remember this. And about the charges, there is another one. For the charges, all you have to remember is, guys, cathode is somewhere cation goes. It's where the cation goes, that's called cathode. And anode is where anion goes. Anode is where the anion goes. Just remember this, guys. This two things that I told you right now, it is true for every single cell out there. Cathode is where cation goes, anode is where anion goes. Be it electrolytic cell, be it electrochemical cell. This particular method that I told you, that is always true. And the second thing is, anode would always undergo oxidation, cathode would always undergo reduction. Okay, very simple things. I don't want you to make mistakes in these ones. All right. So that was the other thing. Now let's move on to the next one, which is these kind of questions, guys. So I would suggest all of you to pause this video now and just try to find out the answer to these three questions. What are the questions being asked you? So like they have given you three equations, they're asking you to figure out the Nernst equation for these three questions. That's it, right? Very simple question. I want you to pause this video now and I want you to solve these three questions real quick. Give yourself 30 seconds for each question, guys, right? So I guess by now all of you have tried solving this question. So now I'm going to tell you how to solve this one without making any silly mistake. There are multiple places where you can make a silly mistake in this question. So I'm going to give you a method, guys, which can give you an answer without any mistakes that you can do. So it's like even if you try to, you won't be able to make any mistakes in this question. Now, for these kind of questions, always remember the Nernst equation is written as, let me just zoom in a little bit. E cell is equals to E naught cell minus 0.059 by n log of, now write till here first, okay, and guys make sure that you are writing all the equations once, at least once, before you go to the exam. Even sometimes what happens is we are under a lot of pressure, right? We are so much nervous at that moment, we sometimes forget, sir, whether it was a minus or plus. You won't understand what I'm saying right now. When time comes, you'll be able to understand what I meant that day. So always write the equation once at least before you go to the exam. Okay, just remember this advice, and it won't take a lot of time from you, right? So just do this. Don't try out your luck at all, guys. I do understand that you have given JEE recently. Those who have given JEE, you have pretty much confident with everything. Still this. Okay, just listen to this advice. Just write the equation once in the morning before you go to give the exam. Okay. Now, E naught still minus 0.059 by n log of something by something, right? So what by what? First, in this situation, you are going to look into the equation that is there. Okay. Now, in this equation, whichever ion comes first, that is the ion you will be writing on top. And whichever ion comes next, that's the ion you are going to write. Right? So even if you try, you cannot make a mistake in here. Right, guys? Now, what is the value of n? And if there is any stoichiometries up there or not, that is also we have to figure out. Now, what is the value of n? Guys, tell me, Mg to Mg2 plus, it would be a 2-electron transfer process. So is Cu2 plus to Cu. So the value of n is definitely is going to be 2. Correct? So this is going to be the final equation to this question. Right? Very simple. Now, let's see how many of you could solve this question. So for this question, guys, let's write everything down again. E cell is equals to E naught cell minus 0.059 by n log of. Just follow the same method through which I'm doing, guys, step by step. First, the first ion, which is Fe plus 2. Yes, it is Fe plus 2. So first write Fe plus 2. And then the second ion, which is H plus. Okay. Earlier, the number of electrons transferred in both the equations were exactly the same, right? The number of electron transferred in the Mg2 Mg2 plus and Cu2 plus Cu were exactly the same. That's why, guys, we haven't faced any difficulties. But here you'll be able to see in the first reaction, the number of electrons is 2 electron transfer process. But in the second reaction, if you see, H plus turning into H2. So this is not like H plus to H2. If you see, H plus is plus 1 oxidation state and H2 is 0 oxidation state. So you might figure out, like you might go like it's a 1 electron transfer process. So guys, as we can see now, in the left hand side equation, like this equation and this equation is not having similar number of electrons. This is the situation where you have to be extra cautious now. Okay. So what you have to do is, first you have to balance this equation. Okay, both the equations. So first, let's write down the first equation over here. Fe turning into Fe2 plus 2 electrons, correct? And the second equation can be written as H plus turning into H2, right? So to balance it, first I'll be giving 2H plus 2H2 and 2 electrons to the balance, right? Now, after writing these two equations, guys, you have to write down the final equation. So in the final equation, this 2 electron cancels out. So you come up with Fe plus 2H plus gives you Fe2 plus H2. Now if you see in the final equation, Fe2 plus is fine. There is nothing wrong about Fe2 plus. But if you see hydrogen has a stoichiometry which is 2. That means, guys, this will be hydrogen square. This is something that you are highly prone to make a mistake. So H plus square will be here, not H plus only, right? And don't worry, this will be 2 only because you can see that in both the equation, this is the 2 electron transfer. Okay, do practice these kind of questions as well. What would be this question? The answer to this question. So I'm not writing the rest of the thing. 0.059. Now see, I can see this one is a 2 electron transfer process and this one is a 1 electron transfer process. So I can clearly understand more electron transfer process will be written here. So 2 log of Sn2 plus would be on the top, and again H plus would be having a stoichiometry of 2 if you balance these equations. So it will be H plus square. This square and the stoichiometries are the things, guys, that you have to be extra cautious about, right? From this electrochemistry chapter. Okay. Once you know which all places are there where you can make mistake, you can eradicate them. Okay. Don't be naive in order to figure out your weak points, guys. Figure your weak points out. That is going to be the best strategy for you going forward. Okay. Right now, I'm giving you the most important portions, the most places where most of the students are making mistakes. I'm giving you that right. Okay. Now, again, which I feel like one of the most important topic or like one of the most important point of today's discussion is nomenclature based approach. Many of us are very good with organic chemistry. When it comes to the reactions, we find it very fine, very good. And we find it very easy as well, right? We are very good with that. But what actually happens is, guys, the way we practice at home and the way the questions come are exactly different. So let me tell you what I mean here. Let's say I'm giving you a question which goes like, convert anisole to picric acid. Let's say I've given you this question. Or let's say I've given you this question. Um, Something like, let's say, convert orthocresol to salicylic acid. The point is, guys, you might have practiced a lot of conversion, but you will understand my point. I might not be giving you some question that you won't be able to solve right now. Maybe you can go like, sir, I know what is anisole, sir, I know what is picric acid. My point is not that, guys. Try to get my point here. My point is they can give you a question with a particular name that you might not be able to decode at that moment. Right? So I am suggesting you what I'm suggesting you is make sure, guys, you are when you are learning organic chemistry, when you are learning those questions and stuff, make sure, guys, you are looking at the names of the molecules. All right. Whenever they're going like, let's say, NN dimethylaniline, you have to convert it to, let's say, salicylic acid. Then you would be able to figure out the answer to that question only when you know the structures. Although you know every single step to this question, let's say if I give you the molecules, the cresol and salicylic acid, you might be able to solve this question within a minute or two. But the point is, you won't know the structure, and you will be struggling with that to figure it out, even after your very good preparation to practice. So make sure you know the nomenclatures of every single organic compound, specifically in organic chemistry, not in inorganic chemistry. You have seen those ABCD kind of questions. There also it would be important. Like they would go like A is reacted with NaOH to get B, B is reacted with something to get C, C is reacted with something to get D. In those kind of questions also they can put these kind of names in there, guys. So make sure your approach of learning organic chemistry should be like you are focusing more on names. Whenever you are revising it, make sure, guys, you know the names to every single molecules. If you see the back exercise of NCERT as well, you'll be able to see these kind of questions a lot. And even after your preparation is good enough, still you will be finding it a little difficult when you look at the NCERT back exercise questions. So I would suggest you to look at the back exercise question for every single chapter once. Go through it once to understand what's my point of discussion right now. Okay, so you need to have a nomenclature based approach to every single question. I have been seeing that, watching that, many of you have been struggling with the nomenclature of coordination compounds as well. Guys, sometimes we don't feel like going through the nomenclatures at all because it's pretty boring. I'm not asking you to read the rules and everything, guys. Just practice some of the examples. Look at the examples and figure it out once. Okay. Now that was it. Now, guys, one of the important points I can say, but not the most important points though. Sometimes what actually happens is, let's say there's a question. Has happened with many of the students as well. Let's say there's a question. Question number one. You have read the question has two parts, A and B. You've read it, and you have figured you know that you can solve both the questions. And the clock is ticking at 30. You have 30 more minutes left for the paper to end. Okay. And let's say this is the second last question. Let's say this is the 22nd question. You have to solve 23rd question as well. Then you have to again recheck all the paper and all. So right now you are in the rush, right? You have to solve a lot of questions right now. You're in the rush. This is when you're capable of making this mistake, guys. What you do is you can understand what my point is, and I guess many of you have done that in one stage of your life, right? I guess in the younger classes, anywhere might have done this kind of mistakes. That you knew how to solve both the questions, but as you were hurrying up in order to solve all the questions, you couldn't see the B part while solving it. While reading the question, you have seen it. So as a result, that stays in your mind that, okay, I know how to solve that question. I've seen this question. So you might not have missed the question when you have read it, but you might have missed the question when you are submitting the paper, when you're writing the questions. At that time, you might have missed it. So always, in the end, after rechecking all the questions, guys, give yourself 2 minutes to check whether you have answered for 70 marks or not. Do the calculation of every single question from your copy, whether you have given 70 marks answer or not. If you haven't given it, guys, that can give you, if you have made this kind of mistake, that would be recognized right then and there. Correct? So this is one of the important points I would rather say. If you are prone towards making these kind of mistakes, we know each other, right, guys? We know ourselves. If we are prone to make this kind of question, guys, so this is going to be your remedy. So do recheck the total marks whether you have given the test in the proper, like with all the questions being there or not. Okay, so this would be your advice for that. Now, coming to the mistake that I have done, the reason behind the mistake that I have done is sample papers. You can understand, guys, we being teachers, we are more inclined towards explanation, right? We explain things to you. We show you the shortcuts, but we are not really the one who gives papers, right? Who give tests regularly. We don't do that, right? I can tell you how to solve a question because I've done that once. Now, once I'm out of touch of giving the test, so you can clearly understand I am not going through that segment over and over again. And as I am not doing that, as a result, guys, I have prone to make mistakes because I don't know how to manage time at that moment. I don't know when to speed up, when to slow down, right? So I want all of you, if you are in a situation where you are in a dilemma that, sir, I have a lot of things left for revision and I haven't solved a single sample paper, guys, mark my word, read whatever things you want to, revise how many times you want to. If you are not solving at least 5 to 6 sample papers, you are definitely gonna make a mistake. You're definitely not gonna make a good score in there. Because, guys, it's like this is something. This is an example that I give to every one of my students, which is like, let's say you know how to hit a six, you know which balls, the full length delivery, you know how to hit a six, and you know how to place your arms, you know how to lift your bat, you know every single thing, but you have never played the game. You have never been in the pitch. So, guys, you would never be able to perform there. That's much I guess. This much I guess we can all understand here. So, I would suggest you to look at the papers. Try to go through the real situation that you're going to go through at that time. Because when you look at the paper, when the question comes, if you have ever seen it, guys, it's not that easy to recognize. The questions are not easy to recognize if you haven't solved enough papers. Even if the question comes and you know this, still you won't be able to recognize at that moment. If you have ever been in this situation, if you have ever felt like, sir, I don't get the question, and most of the time I don't really understand whether the question is even from the syllabus or not, then, guys, this is the advice for you. Make sure that you are at least solving 5 sample papers before you go to give the exam. Solving means, guys, not going through it. You're writing it. You are writing it under the time that you have. Because otherwise, guys, you'll be under a big trouble. And if you're planning for a score more than 95%, if your target is like that, more than 95%, so mark my word, guys, you have to give at least 15 papers to 20 papers in order to get this score, because it's not about your knowledge. The mistake that I have done was not about my knowledge, it's about the practice, right? It was never about the knowledge. I'm not I'm not second guessing your knowledge right now. I'm telling you, guys, after coming back from the paper, you're not supposed to have a regret that I could have solved this paper, I could have solved this question, but for this and that reason, I have made the mistake. I might have overseen the question. I might have not, made a silly mistake in the calculation. So that's why, guys, that was the entire agenda of askIItians today, for keeping this kind of sessions so that you can perform at your best in the CBSE exam. We'll be coming back with this kind of webinars. I guess you have found this webinar very, very useful. So just hit the like button and subscribe to our channel. We are going to come back with more important webinars like this. So stay tuned, guys. And definitely, if you are a student of askIItians, we are running the revision batches right now. We do sometimes feel like coming to the classes, we are not gonna, like, it's a revision, right? And I am also doing revision at home. So coming to the classes is not necessary because I need some time with myself right now. I'm telling you guys, in the revision batches, we are not really revising the topics. We are solving sample papers, and I am actually showing you which all places are you gonna make mistakes, even after your 2 or 3 times revision is over. Even after that, what all mistakes that there that we do. So this kind of discussion is happening in every day, every single day in your revision batches. So if you are a part of askIItians, make sure you come to the batches. And if you're not a part, just stay tuned with us. We are going to come up with more important webinars like this. So today, let's just keep it up to this for today, guys. See you in the next session. Bye, everyone.